Hi, this is our math project. So for the first one, Rich got a boring raisin bran box and we measured it in terms of width, length, and height, okay? So they were actually pretty nice. We got 6 centimeters for the width, 19 centimeters for the length, and 27 for the height, because it's tall, taller than it is, whatever. We needed to keep the same volume and make the basic cube, but minimize the surface area, because the question asks for us to minimize the material used. So we found the volume. 6 times 19 times 27 is 3,078, and that's our volume. And the volume of a, well, that's the volume. And we needed the volume, we needed the new package to be a square base. So the volume of a rectangular prism with a square base is x squared times h. Instead of length, width, height, it's length, width, it's the same thing. Anyway, so we have a secondary, where's Ms. Tebow's eraser? We have a secondary formula right here. Our primary formula is going to be about the surface area, because that's what we're trying to minimize. So the surface area of a rectangular prism with a square base is 2x squared, the areas of the top and bottom square, plus 4xh, the areas of the, the height things. So there's our primary equation. So what we're going to do is we're going to solve for h in this secondary equation and then plug it back into our primary. So h is, using the magical powers of algebra, 3078 over x squared. Okay, so I'm just going to really quickly sub that in right here. Put this where h was in our surface area equation, like so. Now I'm going to simplify this a bit, because this would be a bad thing to differentiate. It's going to say something else. So it's still 2x squared. These x's cancel, and 4 times 3078 is 12,312. So I cancel the x's and I multiply this to the top. So 12,312 over x, okay? So there is our primary equation with the substitution. So now we're ready to differentiate. 2x squared differentiated, I'm going to put SA prime, so you're still with me, is 4x, multiply the exponent, plus, and the derivative of this is, well, actually, here, I'll do over here. It's the same thing as 12,312 times x to the negative first power. So it'll go down to negative 12,312 times x to the negative second power. And I can rewrite that as minus 12,312 over x squared. That's our derivative. Now we have to set it equal to 0, so we can find the extrema of the surface area, the minimum specifically. So I'm going to do that over here. That's squared. So we've got that. We add this whole thing to both sides. So they're just equal to each other like that. Cross multiply. 12,312, that times that, is equal to 4x cubed. Divide this by 4, divide this by 4, we get, what's 12,312? Oh, 3078, there we go. 3078 equals x cubed, and x equals 14.55. But not SN, CM. So there's our dimension. That's x, the side of the bottom base. We still have to find h, because it says find the dimensions of the least amount of packaging required. So h, well, we go back over here, we plug in 14.55 into the h formula. 14.55 squared is, I have no idea. But all I know is that when you plug this back in, you get h equals 14.55. So what we concluded is that the best way to retain volume, 3078, and minimize surface area, to the minimum surface area possible, is to have a cube with all sides 14.55. In terms of domain, I guess Ms. Gregory said see what x goes to as h is 1, and that would be, I guess, 30 radical. Poop. Nah, maybe we want to clip this part of the video. She never gave us an answer for domain. I did that nicely up to there.